how parallel lines have the same slope. Now we're going to talk about perpendicular lines. And here's the key phrase here. The slopes of non-vertical lines that are perpendicular are opposite reciprocals. And we've worked with opposite reciprocals before, so this shouldn't be anything terribly new to you, this wording of opposite reciprocals. But they give us an example. If the slope of a line is 4, and I'm going to say 4 over 1, then if I want the opposite reciprocal, then what I do is I flip the fraction, and if it's positive, I make it negative. If my initial fraction were negative, I would then make it positive. You give it the opposite sign, and you flip it. That's what an opposite reciprocal is. And the one thing we know about opposite reciprocals is, if I take two numbers that are opposite reciprocals of each other, and I multiply them together, I should always get -1. This is another way you can find out if two lines are perpendicular. If you take their slopes and multiply them together, you should get -1. So here, I'm going to look at the outline of this company's new logo, and I want to see its angle DFE, which I'm going to highlight that in red. I've got angle DFE. I want to know, is this angle a right angle? And you can never just say, yes, it's a right angle because it looks like a right angle. That is not okay to say that, because we can never just assume something in math. So what we need to do is see, is DFE a right angle? Well, if it's a right angle, that would mean that DF, segment DF, is perpendicular to segment FE. That would mean they make a right angle. Well, how can I do that? Well, I can find the slope of DF. So I need to find my coordinates here. If I go over 4, up 6, I find out that D is 4, 6, F is 3, 3, and actually, I'm doing this a little off of how I should be doing. I'm going to do line segment DA and line segment BE. The reason I'm doing that is because F isn't quite exactly on a point, but A is, and so is B, so I can use those to be more accurate. So A is actually 2, 1. E is going to be 7, 1, and C is 2, 6. Again, just giving coordinates for all these points that I need to use to find the slope. So I'm going to find the slope of DA first. So that would be 6 minus 1 over 4 minus 2, which gives me 5 over 2, so I get 5 halves. Now I'm going to find the slope of BE. So I'm going to do 6 minus 1 over 7, 2 minus 7. Oh, and I just realized I found the coordinates of C. Coordinates of B are actually 2, 3. So this should be a 3, not a 6. And I get 3 minus 1 is 2. 2 over -7 is -5. This gives me -2 over 5. And notice, my slopes are opposite reciprocals. So is this a right angle? Yes. Because these lines are perpendicular because their slopes are opposite reciprocals. That's the definition of perpendicular lines. Their slopes are opposite reciprocals. Notice I just flipped the fraction and also changed the sign. Now, is each pair of opposite sides parallel? This is actually really easy. I'm not even going to make you do the math here, because notice, C and A, GE, these are two vertical lines. Obviously, vertical lines are parallel. And then if we look at side CG and AE, those are horizontal lines. Those are obviously parallel as well. So the answer is there, yes, as well. We can just see that by identifying that they are vertical and horizontal lines.